Now let's take a look at what happens when we take I, the imaginary unit, and we raise it to powers which are positive integers, so numbers like 1, 2, 3, and so on. I suppose we could also throw 0 in there. So let's start with I to the 0. Anything to the 0 power is 1. I to the first power, well, that's just I. And we know I squared is negative 1. Now let's do I cubed. And I cubed, we can rewrite that as I squared times I, using properties of exponents, and I squared is negative 1. So this is going to be negative 1 times I, or more simply, negative I. And then finally, I to the fourth is going to be, well, we can write this as I cubed times I. I cubed, we already discussed what that is. That's negative I. So this is negative I times I. And now I times I is negative 1. So this will be equal to negative 1, which is just 1. Let's do a few more. So I to the fifth, that's I to the fourth times I. And I to the fourth is 1. So this is going to be I. I to the sixth is I to the fifth times I, which I to the fifth is I, so I times I is negative 1. Again, this first I coming from I to the fifth being I, and then the second I was here from our simplification of exponents. I to the 7, I'll leave it to you to figure out that that's going to be minus I, and I to the 8th is again 1. So we see we have a pattern here. If we start at the top, go 1, I, negative 1, negative I, 1. I, negative 1, negative I, 1. And what I'd like to notice is that all of the I to a 4 times something power gives me 1. So in words, I to the 4 times some integer power, that is a number like 0, 1, 2, 3, 4. So I to the 4 times integer power equals 1. Another observation from this pattern is if you do I to a power which is 1 more than 4 times an integer, then you get I. So for example, if we were to continue this pattern, I to the 9th, we would find that to be I. So I to the 1 more than 4 times an integer is I. These observations, it's called the cyclic nature of I. When we do I to powers, the powers cycle. So I squared is 2 more than 0. I6 is 2 more than 4. If we did I to the 10th, that's 2 more than 8. We would get I again. Excuse me, we wouldn't get I, we would get negative 1. That's the pattern that we have. So negative 1. And so if you have I to a power which is 2 more than 4 times an integer, then that's going to be I, and you might be able to guess that if you do I to 3 more, a power that is 3 more than 4 times an integer, you get negative I. We can go look back at our pattern here, and we see negative I for I cubed and negative I for I to the 7th. Now we can use this cyclic nature of I to be able to evaluate I to very large numbers. So for example, what is I to the 37th power? Now, before we do this, it will be useful to remember some long division and a result from some long division. So what I'm going to do is I'm going to divide 37 by 4, and we're going to write out a result from our long division. So if we wanted to do 37 divided by 4, well, that would be, I suppose 4 times 9 is 36, and we're left with a 1 here, and this 1 is the remainder. We've all done this in school, but I'd like to remind you of something that perhaps you've forgotten. What this means is that 37 is equal to 9 times 4 plus 1. So our remainder goes here. The result from the division goes almost there. 4 goes here, and 37 goes here. And what we see is that 37 is 1 more than 4 times an integer. So 37 is 1 more than 4 times some integer. And specifically, it's 1 more than 4 times 9. I think it's useful to describe what this means in terms of the cyclic nature of I. So, and what I mean by that is to explain what would happen if we were to make this long list of I to powers for I to the 37. So, of course, we have I to the first, that's just I, and we would do a bunch of work and we'd get to I to the 4th is 1. Then we would do a bunch of work, we'd get I to the 8th is 1. Then we'd do I to the 12th, we'd find that to be 1. I to the 16th, that would be 1. Some more work, I to the 20th, I to the 24th, I to the 28th, I to the 32, I to the 36. And notice that this is at the I to the 36, this is the 9th time I've written this. So here's the 1st, 2nd, 3rd, 4th time I've written it, 5, 6, 7, 8, 9th time. And to get to I to the 37th, you have to do this cyclic nature of I, this pattern 9 times, and then go 1 more to get to I. But of course, if the number of the exponent is quite large, you don't want to write this over and over again. So you can quickly find out how much more than 4 times an integer a number is by dividing it by 4 and checking this remainder. So since 37 is 1 more than an integer, that means that I to the 37 is going to be I. If you had a different example, something like I to the, let's say, 113 power, and you wanted to know what this is, you could take 113 and divide it by 4. So 4 times 2 would be 8. We get to 33 here. 4 times 8 would be 32. And our remainder would be 1. And so since our remainder is 1 when dividing by 4, this is going to be the same as I to the first. If you wanted to do I to the 114, you would find that instead the remainder would be 2. And so this would be the same as I squared, which is -1. And finally, if you were to do I to the 115, you would find that the remainder when you do 115 divided by 4 is 3. And so this is I cubed, which is -I.